Hello guys. So today we're going to solve this longest consecutive sequence problem. That is the problem that we're going to solve today. And let's first dive into the description of the problem. So we are given an unsorted array of integers, numbers, return the length of the longest. We need to return the length of the longest consecutive element sequence here, right? So, and we are going to do this in O of n times. That is also to be considered. So we're going to use a similar approach to like um, to a pointer approach. Let me just show you how we can actually do it. Let's see. Let's first, dive into an example. Let's see how it goes. So we have this number array 104, 200, 132, and we have to find the longest consecutive sequence here, right? So if we look closely and also to like visualize it properly, I think so we should actually draw some diagram or something here. So let me just draw a line here, right? Um, Let me just see. Yeah. Okay. So we have a line here. Let's, visualize this uh, array on this line. Let me just draw it here. So for example, we have, let me just try to show this up. Okay. So we have like this here, like for example, 1, 2, 3, and 4, right? And then we have 100 in some distance here. And then we have like 200 on some distance, for example, here, right? If I may write this here. Okay. So we have uh, a visual form of this like number array in a line, in a sequence line here. So like if we actually like see this, we have like 1, 2, 3, 4. That is the sequence of length 4, right? And then we have 100, that is only 1, because we don't have any sequence before it or after it. And then we have 200, and there is no sequence before it as well, right? So this is also occurring one. So if we ask the question how, like, if in the visual eye, in the human eye, we can actually like pretty much solve it in instance. But when we talk about like writing a program, how can we actually identify the pattern to solve this problem, right? So if you look closely, what we have done so far, we actually like looked up ahead of the problem. Like, for example, if this is a particular number, we are trying to identify if there is some element after it, right? And if we don't find any element after it, then it means we don't have any number occurring after it, so it doesn't actually have any range, right? So we can actually just skip this number and skip this number as well altogether, and just focus on elements that have a range with it. For example, if we talk about 4 here, for example, if we let's say we have 4 here, right? We have 4 here. We if we actually like check after 4 there is no element, but before 4 there is an element. But the thing is we need to ignore this 4 at the moment, because the thing is we need to find a number that has elements after it, not before it. So this we need to find a number that has a starting range, right? So for example, if we come across one, right? If we come across one here, we can actually see we have 2 after it, we have 3 after it, we have 4 after it. So what we can do is we can use some sort of an array, some sort of loop to actually iterate and see if the particular element is actually present in the array given or not. For example, if we come across one, we can actually add 1 plus 1 equal to 2, right? And we can actually see if that 2 is actually present in the number array that is given or not. And then if it is found, then we can actually iterate further. We can actually iterate further until or unless we actually get an element that is actually not present in the array. So what we can do after, for example, let's say we come across 4, 4 plus 1 equal to 5, and 5 is not present in our like array, right? So what we can do is we can take that 4 and see if like the current maximum length that we have found, for example, we have found only one that is the maximum length, and we can take the max out of it, right? We can take the max out of it and we actually get 4 out of it, and then we can just return at the resultant, like after all the computation has been done, we can just return the number, right? Return the number. So I think that that's how the major, like, this is the easiest way to solve this problem, to just iterate, find a number, try to combine, like increment it by 1 and see if we can actually find the number in the array given or not. And if we found it, we can actually just continue doing it. And if we don't find it, we can just, like get the max out of it and store in our local variable and return after all of the computation has been done, right? So let's dive into the problem. So so the time complexity of this problem is going to be O of n, because we are just iterating this O of n times. Even if this we are using this loop has a constant number out of it. We're not like iterating it like O of n square. We're using some constant variable, constant number value that is to be given. So we have O of n complexity, and talking about space complexity, that is also O of n, because we want to first convert this number array into a set, right? Because we want every number to be consistent, right? We don't want any repetitive numbers coming up in our in our array. So we want this to be a set. So this is why we need to store this as a set first. So that is the space complexity here. So let's dive straight into the problem and try to solve it. So what we're going to do first is to initialize a set here, right? And then what we're going to do is to initialize the longest integer here. That is going to be 0. And what we're going to do next is to iterate this number set, right? And what we're going to do here right now is to check if, like, what we're going to do is to check if n plus 1, n minus 1, sorry, n minus 1 not in num set, because we want to check if there is like no previous integer in that array. Like if there is no previous integer, then that means we are actually like going with the starting point, right? That what we are taught earlier in the program as well. We are going to start. We need to check if there is no previous, then we can start from that number, because this one has no previous, and we can start from here, right? And then what we're going to do is to check, like let me just check longest, and local longest is equal to 1. Now what we're going to do is to use a while loop, right? While n plus local longest in num set, right? And what we're going to do, local longest plus equal to 1 and longest equal to max of longest local longest. And finally, what we can do is to return the longest. Let me just confirm. Num set nums, yes, num set, and after that we can check if there is previous. If there is no previous, then we can just use local longest and start checking if there is something we can actually find. And then what we can do is to return this longest. Let me just run it one more time. Okay, let me just submit it. So yeah. So hopefully you guys actually like this video. So do present your views on the comment section below. And if you like the video, do like and subscribe to the channel. So see you in the next video. Take care, bye, guys.